So what we learned from Austin's experiment was moving charges create magnetic field, correct? So this is what we have. Now then what did we learn? See, we have a charge Q, and then charge Q emits electric field, right? So because of the electric field, force is there, right? Then what did we learn? See, we have charge Q, and let's say the charge Q is in a magnetic field B, right? So moving charges produces magnetic field. This is also we have learned, right? So now what we'll do is, see, we have a charge Q, it's moving with a velocity of v in a magnetic field B. Okay, so this is what we have. Now what will happen, we need to know. See, one thing what we know is, if a charge is moving, that produces its own magnetic field, right? And we have an external magnetic field, right? So the two magnetic fields will interact with each other. Alright, so both of them will interact. So if two magnetic fields interact, see, two north poles, if they come together, they'll repel. North and south, they'll attract. So some sort of attraction or repulsion will happen, correct? And it's not just that. Here we have electric field from the charge, and we also have magnetic field, correct? So both electric and magnetic force acts on the body. Alright, so since we have both electric and magnetic force, the net force acting on the body is called Lorentz force. Alright, so I repeat this, the net force is what we call as Lorentz force. Understood? So we have net force is equal to net electric force plus net magnetic force, correct? Now coming to the electric force is what? QE, correct? Where Q is the charge and E is the electric field, right? Now see, to figure out the magnetic force, look at this. So what we have is, we have a magnetic field B and we have a charge Q, and the charge Q is moving with the velocity of V, correct? Now there will be force acting on the charge. So that particular force is nothing but the magnitude of that, or what you can say is the magnitude of the magnetic force is the cross product of V and B multiplied by the scalar quantity Q. Okay, so it is the cross product of V and B multiplied by Q, correct? So see, if you look at the figure, we have the angle to be 90, correct? So the cross product becomes 1. So we have F proportional to BQV. Alright, or since we took, if you take the actual formula itself, then we have F is equal to Q into V cross B, correct? So this is the magnetic force, and the electric force was QE. So combining these two, we have F is equal to Q into E plus V cross B, so many Newton force. So this is basically Lorentz force. Okay, so what Lorentz force tells us is that whenever there is a charged particle in an external magnetic field moving with a velocity of V, we have two forces acting on the charge, the electric force and the magnetic force. Okay, the net force is given by F is equal to Q into E plus V cross B. This is basically the Lorentz force.